Good morning or afternoon, whenever you're viewing it. It's Mr. Serpent, and we are going to move into our second to last unit of Algebra 1. We're going to talk about briefly for a second, or maybe a minute, correlation, and then line of best fit, which will encompass the next couple days, and then we will work on direct and inverse variation, and then you will have completed Algebra 1. So, let's get started. What correlation is basically which direction is the data trending. So my warm-up here will serve as those notes. So is the data trending up, down, or neither? Well, here you see some lines that are kind of just across. There's not really a direction. So that would be no correlation. And then this one, it's kind of, you notice, start about here. There's a little trend line right there. That would be trending up. So that means that this one is positive correlation, which would leave you to know that then if it's not positive or no, then it's negative, which means that it trends down. That's pretty much the basics of correlation. We don't need to go into too many details with that. So that's what correlation is. You won't really see it on any assignments. Now, line of best fit. Make sure that you follow along because this one can get tricky very quickly. What you need to remember is our equation for the slope of a line, which is y equals mx plus b. I'm going to write some things in that are a little different. You will have to use Desmos for this. So what I'll do is I need to type a certain, in line 1, I need to type a thing in. And line 2, I need to add a table. So in line 1, I write y1 squiggle mx1 plus b. Now, if you're wondering, how do I get those? Then what I'll do is I have my cursor right here. I will click y. To get the 1 below it, I'll just click 1. To get the squiggle, I will do ABC, and it's right over here next to the comma. And then stay on here and do M, go back, X1 plus ABC, B. Now, if you're on your keyboard and you just type the 1 or press the 1 next to Y, then you can type it in like that. But this is how you might see it on your phone if you're doing it. Now, keep in mind, this will take a little bit to set up. Once you are done with the setup, though, it doesn't take a lot of time to do many of these problems. So then my second line, so I'll click, I've got my first line. In my second line, I'll click the plus sign up here. I'll add a table. One thing that's important to note, I have 1s up here, and I have 2s down here. What I need to do is change one of them. So I'll click right here, backspace, make it a 1, click right here, backspace 1. Now notice that those numbers match. I have y1 and y1, x1, x1. What I'll do, back over here. So line 1 was that equation, line 2 is our table. Now, when it comes to a vertical table, your x's will always be on the left, your y's will always be on the right. And we're going to find the equation of this graph that's over here that I crossed out, but you don't need it. We're going to find the line of best fit, which essentially is a line that evenly splits how far apart all the dots or data points are. So I have my years, which are right here. Those are my x's, so I'll type them in. So I have 1964, 1968, 1975, 1983, 2001, and 2005. I will now type my y values, so this right column over here, 1580, and you notice a line starting to appear. And then I have 7175. Oh, I want to make sure I type in the next 1750. Enter. 1940. 2510. 3420, and 3450. And if you look, every x has a y, and that's going to be how it will be when you do these. Now, if you remember from up here, I have y equals mx plus b. That's going to be our line equation. So, if you look over here on Desmos, I've got, what do you know, an m and a b value. You're going to plug those in for y equals mx plus b. So I have y equals m, which is 48.413. You will typically go out to the third decimal place. If it's a large number like b, you're going to put the whole number. But if it has multiple decimal places and it has more than 3, go out to the third. So y equals 48.413 x plus, well, our b is negative, so I'll make it minus, and then 93,544.4. So that is our line of best fit. What does that tell me? I can plug in any x, so I can plug in the year, 1964, 1968, and later units will be like, well, if this is line of best fit, tell me what would their yield be in 2010? So you can use this to predict. And that will be a later unit. But that is all we're doing, is finding this. Now, what you don't want to do is hit X on these. You don't want to hit these X's over here. What you will do is I will scroll down to the next problem. And then, going back over here, scroll down to the bottom of my table, and then just hit backspace multiple times. Notice it's clearing each line. Don't hit it too fast. And then my setup is still there. If you hit the X's, you'll have to reset it up, make sure that the lines match. You don't want to really clear it because it does take some time to reset it up. But if you are, let me make sure I say it. If you're making sure that you want to save time, just clear it just clear the lines in the table. Don't clear the actual equations. What I'm going to do now is the next one. Find the line of best fit for the height and weight recorded for several adults. So I have my height and my weight. Remember, X is always on the left, Y is always on the right. And then I'm going to type them in over here. So my height is 4.65. And then 5.45, 5.7, 5.95, 6.15, and 6.35. And then I type their weight across from it, so 95.8, 132. And notice my line is starting to appear. And this graph over here doesn't match it just because of the scaling, so don't worry about that. So 132, 150, 160, 169, and 187. Now if I click off of it, notice every X has a Y, and then all I have to do is I'm looking for that equation. So I look up here, and I see M and B, and I plug them in. So I have Y equals 52.137X minus 148.647. Notice it goes out to 3 digits. Therefore, I go all the way out to 3 digits, to 3 decimal places. This is all you're doing for this day, and also there will be a second day attached to it, and you're just finding the line. You're not doing anything further. On Friday, you will be, so I'll give you 2 days. On Friday, you will work on predicting. And then the following week, we'll finish our last unit. But that's all you're going to do. Plug in the X, plug in the Y. I'll go ahead and demonstrate it one or two more times. So go down here, don't click the X, just scroll down, click next to this, and then just kind of hold backspace. Don't hold it too far. Still want to clear your table. It's just a pain to make sure that you type it in every time and make sure that they match. So, by examining past tournaments, it's possible to calculate the probability that a school wins their first game in the National College Basketball Tournament. So they have their rank and their probability percentage. What I'm going to do is I'm going to type all those in. So the ranks, I have 1, 4, 5, 7, 9, and 11. Their probability percentages, so 98, 80, 76, 60, 46, and 33. Now, if you look up here, I've got my M and my B, so I type them in, or I plug them in for what essentially is Y equals MX plus B. But I plug in the M and the X, so Y equals M is negative 6.609, X plus 106.257. What that tells me is I would plug in their rank. So my X, remember, this is just to kind of explain why we're doing this unit. Their X is their rank. Their Y is their percentage, their probability percentage. So if I plugged in rank 16, it would tell me the approximate percentage. Now, is it perfect? No, this is a trend line. Notice it doesn't, in this graph over here, it doesn't hit every single point. Actually, it only hits a few of them. That's because it splits them evenly, how far apart each line is. So it's not always perfect, but statisticians and people use these to make sure, okay, I need to estimate real life things like interest rates, stuff like that, stock markets. What is the trend line? How is it going up? Is it going down? It's a little bit more complex, but this is the basics of it. What we'll do is I'll do one more, and then I'll explain your assignment. So right here, the cost of a flight is related to the distance traveled. So I'll go over here, clear out my table, just keep clearing backspace. So I'll type them in. So miles, 225, 525, 800, and you notice Desmos tries to guess what the next number will be, but make sure you just type in the numbers that you have, 1950 and 2250, and type in the cost. Now obviously these are not real costs, but as much as we wish they were, $76.8, $76.80, 99.4, 126, 214, and 223. Look up here, my M and my B values. So I have Y equals 0.091, X, remember, go into that third decimal place, plus 27.034. What that tells me is I can plug in the amount of mileage for X, and it would tell me the approximate cost of the flight related to this specific airline, if this was the real one. Your assignment on Google Classroom will be to work out, we'll not do those, is to work out these ones. You'll work out 10 of them. So I'll actually cross off the 2 I don't want you to do. I don't want you to do that one. And I don't want you to do those, 7 or 12. Also on the back is 2 examples like the one you saw in the video. So if you have questions, ask them. Don't worry about day 6 quite yet. I'll post a quick video about